Good morning, everybody, and welcome to 9-2 Notes, Properties of Parallelograms. A parallelogram is a quadrilateral where the opposite sides are parallel. If the opposite sides are parallel, so if that side's parallel to that side, and that side is parallel to that side, then the opposite angles are also congruent. So that would mean that my opposite sides would be congruent. Okay. If the opposite sides are parallel, then the opposite angles are also congruent. So this angle would be congruent to this angle, and this angle would be congruent to this angle. And that's because of the alternate interior angle theorem. We have two pairs of parallel lines here, right? And so the opposite angles must be congruent because you've got this situation with transversals. So this would be congruent to this, and this would be congruent to this, thereby making them congruent through two pairs of alternate interior angles. If the opposite sides are parallel, then the consecutive angles are supplementary, which means they add to 180. And this is because, so look, these two add to 180 right here. This is because of the consecutive interior angle theorem we learned about way back in the first trimester. And finally, I'm going to erase some of this because it's getting a little bit crazy looking. If my opposite angles are parallel, then my diagonals bisect each other. So let's take a look. That means that those two pieces would be congruent, and those two pieces would be congruent. So let's take a moment real quick to prove that because my angles are, or because my opposite sides are parallel, the opposite sides must also be congruent. So I'm going to start out like we always do. Statement and reason. I know it's been a while. And we begin with our givens. AD is parallel to BC, and AB is parallel to CD, because they're given. And I'm going to start this proof by drawing in something to help me out. I'm going to draw in a diagonal, AC. So I drew in AC by construction, because I can. And what this has done, this has created two triangles that I can work with now. And these triangles are really nice because I'm going to have some lovely alternate interior angles that are congruent. So I can say that angle BAC is congruent to angle DCA because they're alternate interior angles, alternate interior angles theorem. And I could say that these two angles are congruent for the same reason. Angle DAC must be congruent to angle BCA by the same reason. Well, so that's given me two angles are congruent in these two triangles. Remember, if I'm trying to prove two triangles to be congruent, which is my end goal, then I need another piece of information. Well, I've got this shared side AC. So I can say that AC is congruent to AC by the reflexive property. Property of congruence. We're going to be really, really specific about it. Okay. Now, looking back at this, I established that two angles were congruent and a side my two angles, both, we look here, ASA, my two angles touch the side, so triangle DAC must be congruent to triangle BCA by ASA. Well, that's really nice because I can now use CPCTC. Remember CPCTC? Corresponding parts of congruent triangles are congruent. From our triangles unit back in beginning of Try 2 to help me prove that these opposite sides are in fact congruent. Because if these two triangles are congruent, then AD does in fact have to be congruent to BC. That has to be true. So AD has to be congruent to BC because they're corresponding parts of congruent triangles, therefore they are congruent. And AB has to be congruent to DC for the same reason. They're both a corresponding leg in these two triangles. So I can say that AB is congruent to DC, again by CPCTC. Well, I have now proven the two things I wanted to prove. I'm done. QED. So now we have some generic algebra examples that we're going to do to take a look at how we can use these properties to do more algebraic style math. So here I have that AB is 2x plus 2, CD is 3x minus 3, BC is 3x plus 1, and AD is 2x plus 6. Now we know because they're parallelograms that opposite sides must be congruent. So 2x plus 2 must be equal to 3x minus 3. Or we could have written 3x plus 1 must have been equal to 2x plus 6. But if this is true, I should get the same value for x, so I need to solve one of them. I'm going to work on this one over here. I'm going to subtract my 2x. I'm going to add my 3. And I end up getting that x is 5. So now if I want the length of each side, I simply plug it in to the values I was given. AB would be 2 times 5 plus 2, which is 12. So AB is 12. Well, CD must also be 12 because they're congruent. And BC is equal to 3 times 5 plus 1. So that must be 16. So BC must be 16 and AD must be the same. Right? Cool. Okay. ABCD is parallelogram. I want to find the measures of the angles. I can use alternate interior angles here to great effect. I can use supplementary angles. There are all kinds of cool things I can do here, but I'm going to leave you guys to do them. So I want you to show me this in your notes next class. I'll be looking for it. Good. All right, this guy, find the value of x. Well, we know that these two angles must be supplementary because they're consecutive angles. So 7x plus 40 plus 3x minus 10 must equal 180. So simplifying that, I get 10x plus 30 must equal 180. So 10x must equal 150. So x must be 15. Let's take a look at our next kind of quadrilateral. Next kind of quadrilateral is the rhombus. A rhombus is a quadrilateral with 4 congruent sides. This actually makes it a special type of parallelogram. Because remember, parallelograms happen to have 4 congruent, or opposite pairs of sides are congruent. We say that a rhombus is equilateral because all 4 sides are congruent. If the shape is a rhombus, there's also a really cool theorem that says that the diagonals are going to be perpendicular. And if it's a rhombus, the diagonals are going to bisect a pair of opposite angles. So that would be that angle be bisected, and that angle be bisected. And that would be the case as well. Okay. Remember, it's still a parallelogram, so all those cool things about parallelograms still exist. We still have that these are parallel. We still know that these pieces would be congruent, etc. Still know that the consecutive angles are supplementary. So now, given the figures below, find all the missing angles. Well, real quick, if this is a rhombus, those sides are congruent. So looking just at this triangle here, that's an isosceles triangle. So I know that this angle and this angle have to be the same thing. So if I do 180 minus 120, I get 60 degrees. So therefore, each of these two angles must be 30 degrees. And if these are 30 degrees, then these must also be 30 degrees because the diagonals of a rhombus bisect a pair of opposite angles. And opposite angles in any parallelogram are congruent, so this guy must be 120 as well. I want you guys to do this one on your own. Okay, rectangles. A rectangle is a quadrilateral with 4 right angles. This makes it a type of parallelogram also, because if all of your angles are right angles, it ends up that the opposite sides end up being parallel, which of course makes this into a parallelogram. A rectangle, we say, is equiangular, just like equilateral, but with angles, because all 4 angles are congruent. If a shape is a rectangle, then my diagonals are going to be congruent. So that would be that KM has to be congruent to JL. So that would mean that all 4 of these pieces, when they're bisected, because remember it's a parallelogram, they end up being congruent as well. And finally, we have a square. A square is a quadrilateral that has 4 congruent sides and 4 congruent angles. Therefore, a square is also a parallelogram, a rhombus, and a rectangle. A square is also equiangular and equilateral, making it a regular polygon, or the regular quadrilateral. So that means that all 4 of my sides are congruent and all 4 of my angles are congruent. Well, we also will know that my diagonals both are perpendicular and congruent. Lots of cool things with squares. We know that these diagonals must also split any one angle into 2 45-degree angles because it's going to be bisecting. 45, not 40. Whoop. Because we know that the diagonal must bisect the opposite sides in a rhombus. Squares are awesome because all of the properties of parallelograms and all the properties of rhombi and all of the properties of rectangles apply to them. So squares are really cool. They just encompass absolutely everything. All right, that is the end of your notes. Write down any questions you have for your teacher, take a look at Math Excel, and have a great day.